Hello everyone, and welcome to You Ain't Invited Breach, our webinar on web application attacks. This is our second webinar in our series of 6 about security and how we can better it at your company. My name is Mike Licken. I'm a senior technical engineer over here at Encompass, and my job is focusing around implementing security solutions, developing policies and procedures with Mike, and then creating the policies and implementing technically the solutions that we create. Today we're going to kind of talk about some common types of web attacks and how they work and how we can, what kind of information that they're going to be going after and how we can prevent them. As you kind of see listed here, these are straight out of the OWASP 2013 list. Top one, seems like for the past number of years, has been SQL injection. Really hard to stop. I'll talk about why. Cross-site scripting is also another one that's right up there. Insecure direct object references, security misconfiguration, sensitive data exposure, and cross-site request forgery. Also, I threw on here denial of service. That's not technically a web attack that's going to try to steal information from you, so it doesn't make it on the OWASP list, but it is a web attack in the sense that it will cause financial harm to your company if you do get hit with a denial of service or even a distributed denial of service attack. In this webinar, we're going to kind of talk about these 4 things: SQL injection, cross-site scripting, insecure direct object references, and denial of service, and kind of go through how they work, what happens when somebody performs one of these attacks on you, and how we deal with it. Again, these are straight out of the OWASP 2013 list. There'll be a link in the email follow-up that you can take a look at the OWASP list, as well as a number of the information sources that we gathered together to create this webinar. SQL injection. All right, what's that about? So the idea with SQL injection is to inject a SQL query into your web traffic. Basically, fool the SQL server into thinking that the web server is actually requesting this information, because it actually is, but it's on behalf of you, and it's the most common type of web attack out there. It's the hardest one to prevent because traditional firewalls don't help. They're port-based. They just look at the header. Well, generally they're port-based. They look at the header and they go, hey, you're going to this IP address and this port? Good to go. They don't care about if it's a SQL query in there or anything like that. And a signature-based approach generally doesn't work, and we'll talk about why. It's really hard to write a signature based on all the eventualities and possibilities of a SQL query. And it's really easy to steal a lot of information. What we're going to do is just kind of hop over into a demo of how to steal information or gain access to things based on a SQL injection attack. This first one that I'm going to do is entering SQL instructions via a form field. Now, I've set up a Linux box over here just to kind of keep it off of my workstation, but works the same as any, on a Windows machine, OS X, Linux, anything. As long as you've got a browser, you can make this happen. So I've just got Firefox open here. Nothing special. It's just Firefox. I'm going to click on Online Banking Login. I'm going to punch in the username admin because that seems like it would probably be an admin or an account that's there. And for the heck of it, let's just type in El Toro as the password, just because that might be a password they use because their name is El Toro Mutual. Obviously, we got a login failed here. So we know that it's actually performing some sort of credential check on the credentials that we're passing in here. Now, the interesting thing here is we're going to do something a little different. We're going to put some new information in this username and password fields. And you'll see that it doesn't really look like a username or a password. And so we're going to take this and we're going to copy it straight into the password field as ready. So what this is doing, if you look at it real close, is we're basically saying or and then a true statement. So when this website on the back end decides whether or not to let you in. Basically, on the back side, they're saying username. They go back to the database and they say, this is the information that we got from the website. Does username equal this? If it finds that in the database, hey, they're all good. If it doesn't, well then, hey, you're not a user because we didn't find you in the database. But what this is doing is this is saying, can you find this username in the database, or does 1 equal 1? Well, 1 equals 1, so as you see, it lets me right in. And as you can see, I'm actually in as the admin user because that just happens to be the first username in the database. So it just pops me into the first user for the database. Now, this is crazy easy. I mean, all we did was enter that in, and now we're in. We got access to everything. So this is one of the easiest types of SQL injection attacks. And to be honest, you're not going to be able to make this happen in a lot of places anymore because a lot of places are implementing security and code development, things like that, to prevent some of this stuff. But this is the first, this is basically what's happening. And it's like, as you saw, very easy. It took me, 10 minutes to just go on Google and just see what I could find about how prevalent this information is out on the internet. And it's very prevalent, very easy to find, not hard to do at all. Next thing we're going to do is we're going to take it a little further. So we're in, but as you can see, we don't have any access to any account details here or anything like this. We can click around a little bit, but we're really not getting anywhere, right? So what we're going to do is, I've got this software in the background called Burp Suite. It's a free tool that is available online. And basically, you can just go out and download it. It runs on Windows, Mac OS X, Linux, anything that you want to do. Basically, I installed this, and all you have to do is turn interception on. So this is this little button here. So now it's intercepting all the traffic that I'm sending from this box. What I can do with that then is adjust what I'm sending to the website. So for instance, I'm just going to refresh this page. Now, I've just intercepted my request, and you can see this is all my information in the request that I've sent to the web server when I hit refresh on this page. You can see kind of in the bottom here, I've got user information. So obviously username is jumbled, password is jumbled. That's great, no big deal there, because we wouldn't want that to be in clear text. But we have a user ID here. We're just going to try something real quick. We're going to put a single quote behind this just to see how it deals with that. And then we're going to forward it onto the website. Well, if you look at this, we suddenly got this huge error from SQL. Now, normally, you would think, well, that's good. It's not giving you any more information than it should. It's not letting you through. It just basically sends you an error message, and well, too bad. But what we can really do from this is we can say, look at this. Basically, from this SQL message, we can go back and say, oh, well, every time that you refresh the page, this is going back to the SQL server and re-authenticating your user account and basing it on that user ID that we have here. So it's not caching any of that, and also we can attempt to utilize that to do more things now. So we're going to just hit refresh again, and we're going to not put our single quote on there this time because we want to get back to the normal page here. And I've built a couple of additions to my headers here that I kind of just went through and I built them myself, and I just wanted to do it real quick. But basically what we're doing here is we're doing a union select statement, and account ID and account type are table names in the database. Now you might say, well, you don't have that information out of the top of your head. You have to actually dig around, but that's what SQL injection is all about. It's about creating error messages and then using those error messages to find more information. So I got this error message this time. Well, that's not, obviously that didn't work. Let's try something new. Account ID is not an original name for a field in a table. I mean, that's pretty straightforward. Account type, well, okay, maybe you have an underscore in it, maybe you don't, maybe you spell out the word account, but, that's pretty straightforward stuff. You're not going to fool anybody doing that. And then accounts is obviously the table here. So what I'm going to do is I'm going to just refresh this one more time, And on this user ID, since we're going back to the SQL server, every time that we do a refresh, I'm just going to paste this union select statement in here and then forward it on. Just see what happens. So now, look at that. We have all of the checking and savings account for this site. Now, I'll just preface this by saying this site is actually meant to be hacked. It's a temporary site, so I'm not actually hacking a bank at this point. It's a test site. But interesting thing, all we have to do is put that union select statement in our header, and now we have all the account information for everybody at this, supposed bank. That's really easy. We didn't have to do anything. We didn't need a username. We didn't do anything like that, and we're in. So that's pretty powerful stuff. One other thing I'm going to do is, so now I refreshed it, and I didn't have my union select in there, so this went away. I'm going to do one more. And this time, I'm going to do a user union select of the username and password from the user's database. So the idea with that is I'm going to pull the username and password for all the users. Let's even see that. Let's just see if that even works. I mean, obviously it's going to work because this is a webinar and I prepared for it, but let's just see if it works. So we'll select username and password from the users table. And we're going to forward that on. Now, we have all of our usernames and passwords for everybody in that database. This is how SQL injection works. It's very hard to stop. One thing I'm going to show you right now, and I kind of missed before, is I'm going to turn interception off here because it's kind of being a pain in the ass right now. So if we log in, so we did this or 1 equals 1. Well, all this needs to be is a true statement. A equals A. That lets me in. Basically, all that needs to be is a true statement. A word can equal a word. 2 is less than 1, or I'm sorry, 1 is less than 2. Anything that's true will get you in. And that's why signatures don't help. Because if you had to write a signature for every true statement that a SQL database can process, the signature list is going to be huge, just humongous. So that's why signatures are not where we need to go with this. We'll get into how to prevent some of this stuff in a bit. Cross-site scripting. This is the next attack. Sorry, we're kind of burned through this. Cross-site scripting is all about putting something on a page that causes other users to run a script that they don't want to run when they load that page. And the idea is injecting that code into a legitimate website so that people that are going to this website don't realize that something bad is happening. They don't suspect this website because, hey, I've been to this website 1,000 times. No big deal. It's a popular website. Nothing bad should happen to me on this website. But basically, we're hacking that website. It's prevalent on sites that allow user content, and I'll show you why in a second. And the idea is it's used to distribute botnets and steal cookie information and to run a script, but it's all dedicated towards a victim's machine. Now, if you looked at the SQL injection stuff, that was all directed at the server. We were trying to grab stuff from the server, information from SQL, run it on the web server. But cross-site scripting is all about infecting the victim's machine, the client's machine. Now, these are two options. Well, it's an infinite number of things that you can do with cross-site scripting, as the same as with SQL injection. But this is kind of how it works. Basically, you find a spot, either a comment field or a review field, anything where you can put content on a website, and you paste one of these, a script, something like this, into the comment field. That comment is not actually going to show up as visible information on that website unless they're properly sanitizing that input. But if they're not properly sanitizing that input, it's not going to show up actually as a comment on the page. It's going to go into the HTML script and run as a script. So basically, this top one is pretty harmless, but it's basically going to pop up an alert to the user saying, attacked. Or, if you look down at this one below it, it's going to redirect a window to that window inside of where you're at to a specific web page. Now, this could be hidden or it could be visible to the user, depending on what the what the intent is of the hacker. So this stuff is, really easy to get in there too. Basically, these major companies, have good defenses against this, but companies like Amazon, Facebook, any of these companies where you can enter information into their website that posts for other users is where you can make this happen. And then insecure direct object references. This is kind of a general thing, or general description of a, can be a lot of different things. But basically what it does is utilize directly referenced objects in code to steal information. So if you, open up a page and you right click it and you hit view source, is there stuff in there that you can use to attack them? It's a pretty common mistake. It's very prevalent on the web to directly reference certain objects or pages or things like that within your code, or even your, URLs, folder structures, things like that. And the idea is that it's used to plant and distribute malicious software or steal information or gain access to a web server. I'm just going to do something real quick here, and this is a very straightforward type of this attack as well. So nothing too big. But we're just going to click on the personal site here. We're not logged in. We're not doing anything like that. But what we can do is we see that the content, they've loaded personal.htm. Now, what they've done is they're not loading personal.htm as the page itself. They're loading personal.htm as content within this ASP program. So with that, what we can do is we can say, hey, let's load something else. Let's load java.cs, just for, let's just guess something. Well, we see here, error, file must be typed txt or htm. Okay, well, we know that now they're trying to prevent some of these attacks by forcing you to do either a txt or an htm type format. So let's try something else then. Let's just say test.htm. That probably doesn't exist, but we'll give it a shot. We get an error message. Like we talked about, error messages are good for hackers because they know what type of database you're running now. In this instance, we have the entire file structure of your website now. It's in D downloads atorum mutual _v6 website static test.htm. Now, in this instance, it's located on a D drive, but in a lot of instances, IIS runs by default even on the C drive. Now, there's a number of things going into this, but if you were able to grab a URL path here from the C drive, so let's just take this a little step further here. We're just going to go one directory up. We can go, we can navigate this entire directory structure from this ASP code. You can see that we're going upwards in this folder structure. So basically, if we were able to navigate a folder structure like this on the C drive, based on Windows, we would know exactly which files to hit, and as is the case with a number of websites out there, the service running the website has, pretty powerful permissions on the box. We could actually hack that website just by browsing to the file and, stealing information that way. Then denial of service. Like I said, this one is a little bit different from the rest of them that we've talked about today. I wanted to get kind of a good variety of attacks in there, so we're going to kind of talk about denial of service as well. Now, a lot of people probably know what denial of service is. Basically, it's pounding on a website as hard as you can until it can't handle anymore and the site goes down. Basically, that's the idea of it. You'd either try to take down a site or you max out the bandwidth so that legitimate people can't get there anymore. Now, this is generally, it causes revenue issues. If nobody can get to your site, you can't make any money off the site. Also, the idea is it's used as a distraction. So if you want to perform some sort of a hacking attack or something like that against a website, you create a denial of service on the front end and try to hack them from the backside. It's basically, same thing that illusionists do or magicians do. Look over here while I'm doing this. So like I said, there's no inherent ability to steal information with a denial of service attack, but it's used in conjunction with them oftentimes to steal information while using a different attack type as well. So the idea is that most of the time they utilize weaknesses in TCP or UDP protocols. There's ways that these protocols can be utilized in a malicious fashion. There's things like floods, ICMP, ping. You could just set up ping after ping after ping after ping and get millions and millions of these things going on a web server. And if every one of those hits the web server, that's going to cause some significant heartache for that web server. SYN floods. The idea with a SYN flood is if anybody knows how a session builds, you get a SYN, a SYNAC, and an ACK. That's the handshake for a session build. And what this will do is flood you with SYNs. So it's going to say, hey, I got this SYN, send a SYN towards the web server. The web server's like, okay, I'll open a session for you, and send basically a SYN ACK back. But the denial of service, the attacker, they're not going to send the ACK back. So this web server is going to say, okay, well, I'm waiting for you. While that's doing that, this attacker is sending millions more SYNs. So now we fill up all the sessions on a web server just by saying, hey, open up a session for me, open up a session for me, open up a session for me, and never closing these sessions. Now, eventually these sessions would time out, but these things happen so fast that basically you fill up the web server session, and now you're unavailable to the internet until these sessions time out. There's things like slow LoRa's. That's similar, but what that does is actually builds a session, but as the web server's, it's you're grabbing information from the web server as like a normal user would do. Hey, give me this page, give me that page, whatever. But it's saying, deliver that to me very slowly. Sometimes via the TCP window size, sometimes by other things, but it's grabbing things very slowly, grabbing content very slowly, and holding that session open for a lot longer than is normally possible, or that normally happens with a client, and doing that thousands and thousands and millions of times, and causing that type of a thing as well. Are you dead yet, Rudy? Basically, creating a post, or entering information via post, like you do with a table, and basically sending little bits at a time. Basically the same type of thing as slow LoRa's, or even slow read is very similar to that. Basically, the idea is holding that session open as long as you can so that you're using up as many sessions as you can on the web server and causing not necessarily a bandwidth outage for the customer, but just a session count outage on the server. And then distributed denial of service, or DDoS, the idea is that, so, with a lot of IPS, IDS, you can see a lot of stuff coming from one address, and you can say, hey, that guy's obviously denial of service. He's doing a DOS attack on us. Let's just block that IP address. Problem solved, right? Well, denial of service basically does the same thing, except it comes from thousands of addresses. Basically, they utilize botnets. Everybody's familiar with botnets. Malware, things like that have really hit the news the last 3-4 years. Using those networks to send denial of service from thousands of clients rather than just the one. So it's almost impossible to identify where those are coming from and block even those clients. Now, the information targeted. We kind of talked a little bit about this before, but basically, what are they trying to get when they're running these attacks at you? With SQL injection, it's any information that is stored in or can be called by a database. You're running a query based on information that's in the database, and you want to grab credit card numbers, usernames, passwords, anything that's in that database that you would want, you can do based on a SQL injection attack, assuming you find the right query. Again, denial of service, under distributed denial of service, there's no information targeted there. Basically, they're either meant to just cause pain, like Anonymous, you've probably heard that in the news. They're saying they're going to take down Facebook, they're taking down these other websites. They're basically meant to cause pain or be a distraction so that you can run some other attack in the background while admins are trying to figure out what the heck is going on with the front end, you're kind of coming in on the backside and attacking things that way. Cross-site scripting, wow, I'm going to miss this one. Insecure direct access objects, cross-site request forgery, client information, cookies, browser stored info, all that information is kind of what's attacked with these. The other thing that's kind of heavily used is use this to try to proliferate malware into a broad population, and that malware then generally can be used for denial of service attacks, for other types of things, and basically used to attack. So basically, you run a cross-site scripting to develop your botnet, use denial of service to cause pain on the front end, and then you can do SQL injection, you can do whatever else on the back end to grab that information. It's all kind of it's one part of a whole big environment. Now, how do you identify and prevent this stuff? Now, IPS and IDS, they're signature-based. Firewall is porter application-based. These are very ineffective things against these types of attacks because they're not scanning the actual information that's going through there, because the idea is that, especially with SQL injection, cross-site scripting, these are things that actually could exist on a website. This website could actually be calling this information. A lot of times it actually does call this information. Cross-site scripting is just script. It's stuff that exists on the website. So it's hard for a firewall or an IDS IPS to block this stuff because it looks like legitimate traffic. Things that are effective against this. Web application firewall, we'll talk about that in a second. Code verification. Basically, running your code through tools and things to basically verify that you have no openings, referenced objects or directly referenced objects, things like that, that are going to cause some problems with you. And then developer training. Say, hey guys, just because something does work doesn't mean that that's the way that should be done. We'll kind of dig into this a little bit further. Web application firewall. We deal with A10 networks here at the office, so some of the other ones are a little different, but one of the reasons that A10 is one of the better ones out there, in my opinion, the best one out there, is because it requires a sitemap to function correctly. Web application firewall is not even close to a traditional firewall. You think of a firewall and it's like, yeah, it's on the perimeter and it allows stuff in or out and NATs for you, just requests or routes, does other things for you. Web application firewall doesn't do that stuff. Web application firewall actually you provide it with a sitemap, and your developers should have this information. You give it a sitemap of all the types of information that could be entered in a specific field or form. What pages can be called from where, what pages you have on your site, what URLs are allowed, things like that. And because it knows everything that's going on with the site, it's able to say, hey, when you run a SQL injection attack against a website, you can say, hey, or it'll say, hey, that is not a valid request from that page. It shouldn't be happening, so let's block that. Or, hey, you're not supposed to have single quotes or certain types of SQL injection in a form field. Certain things like that. These are not allowed items in a form. Things like that. It's blocking based on that code that is actually coming through. And because of that, they're able to block a lot. Almost all invalid requests. And usually they do also include IDS and IPS signatures, so that in addition to providing secure code and secure input, you're also protecting against things like SYN floods, DDoS attacks, those types of things. And often, these things are built into or can be licensed as a part of a load balancer. F5 does that, A10 does that, Radware does that, things like that. They're part of the load balancer because the load balancer's got to sit out in front of your web servers anyway. You might as well throw the WAF right in front of it. So that's the idea with that. Code validation. There's a lot of tools out there to evaluate and discover vulnerabilities in your code. Basically, you run your code through it, and it says, hey, you haven't sanitized this input, or you haven't closed this tag, or things like that that could be potential inputs for attacks. And it should be run on all code for every revision of your site, of your web app, of your things like that. It should be run always as a last step after QA. Should run code validation to make sure that everything that's in that site is secure. Developer training. Just because something works one way doesn't mean that it's the right way to do it. You know, that as with the case with everything in computers, there's a million different ways to make any one thing happen, but that doesn't mean that any of them are the right way. You know, there's usually only a couple right ways to do things, and we need to stress that sanitizing input, doing that type of stuff, is the right way to do things, and that's the only way to do things if you want to be secure. Again, proper input sanitization, using service user accounts for running websites, things like that, that only have access to certain pieces, only the required pieces of information on the web server, and disabling access to sensitive data. And this is all so that this doesn't happen to you. All right. Again, my name is Mike Lookin. I'm a technical engineer here, and this is my information here, and there's some additional resources here, and we'll send all this stuff out as part of the email afterwards. Thanks everyone for coming.
Just got slammed. Cross the face, my friend.